Hi, this is a little bit of a review video for Chapter 5 in Precalculus, and I'm showing here the 5.5 notes. And why I'm showing this is just to tell you what you need to memorize. So these formulas right here, all the way down to this point right here, you have to memorize and know. Beyond that, anything that I give you here, you should be able to use, but you won't have to memorize. So that's what we're looking at for the formulas. So once again, up through here, these are all the ones that you have to memorize. And I made it a little bit bigger for you to look at. All right, now what I'm going to do is sometimes use this page to come back and explain some of the problems from the review. Now you don't need all these explanations, or some of you might need all of them, but don't use this to just copy. You need to make sure that you can do the problems and try the problems on your own. If you get stuck, this is a guide for you, but you're only as good as how you use this video to help you. Don't just copy it off and those kinds of things, but just try to use it to understand, especially if you got stuff wrong on the quiz and you need more explanation from that. So with these problems, I'm going to start off here with A, which actually says 10, but that 10 shouldn't be there. So if I take this, I want to try to solve this for x. And this is in the interval from 0 to 2 pi. A lot of times we don't include 2 pi because if it works at 0, it probably works at 2 pi, so we don't include that portion of it. So what we do is we solve this just like this piece, this sine of 3x right here is a variable. So I isolate the sine of 3x. Then what I say to myself is, what values of the sine, or what angle measurements of the sine give me a value such as square root of 3 over 2? Well, those values are pi over 3 and 2 pi over 3. Now what happens though is that since this angle or this curve is going 3 times as fast, I'm going to get twice as many solutions as I usually do. So I don't just get 2 of them, I'm going to get 6 of them. 3 times 2. So then I take this sine, this 3x, and I set it equal to these two values. Then to get this next value, what it does is it comes off of this pi over 3. All I do is add 2 pi, and I add 2 pi. Same thing here. I take this 2 pi over 3 and add 2 pi, which is 6 pi over 3. Add 6 pi over 3. Then I divide everything by 3. So these are solvers, and when you see this 3x, a lot of times you want to try to solve it such that you get all of the angle measurements that you need. We graphed this in class too, and the waves go 3 times as fast. You shoot a line through and you get 6 solutions from 0 to 2 pi. This one's going half as fast. So we need the tangent when the tangent value is square root of 3 over 3. Well, that happens at pi over 6 and 7 pi over 6. However, now when I multiply by 2, so I multiply this by 2, I get 2 pi over 6, which is pi over 3. Multiply this one by 2, I get 14 pi over 6, which is 7 pi over 3. That is beyond 2 pi. So I'm only going to get the one solution here. Going half as fast, I might get half the solutions. That's what's happening. This one here, a lot of people mess this up on the quiz because they forget the plus and minus. So when you solve for this and take the square root of both sides, you're going to get the plus or minus right here. So what this makes for is, even though I don't have a speedy angle, it makes for twice as many solutions because I have both the positive square root of 2 over 2 and the negative square root of 2 over 2. So the sine is positive square root of 2 over 2 at pi over 4 and 3 pi over 4. Negative square root of 2 over 2 at 5 pi over 4 and 7 pi over 4. This one here, the trick is to take the sine squared. This sets up kind of like one of those trinomials that you can factor. So I'm going to take this and I'm going to try to get the trig functions in all the same trig value. So I'm going to take the sine squared and turn it over to cosine squared because I already have the cosine here, and bring everything to one side. Once I simplify, then I can factor, and then I can work it out. Sometimes if the sine and cosine are mixed, you can factor out something and it works. But sometimes if you see the sine squared and a cosine, you're going to have to get it all over into one trig function. This one's already in one trig function, so you bring everything to one side. Factor. Each factor generates its own solutions. So this one, sine of x is equal to 1/2, generates pi over 6 and 5 pi over 6. This one, sine of x is equal to 1, generates pi over 2. Going on to E here, this is one that has sine and cosine mixed up. However, if you look at both of these terms, sine is in common with both terms. So you can factor that out. So the sine gets excluded from the cosine. So then these are two different factors that are equal to 0. So either the sine of x equals 0 or this factor right here is equal to 0. So I solved that out. So then I just get cosine of 3x is equal to 1/2, positive 1/2. So from here I get two answers. Sine of x equaling 0, it's 0 and pi. And from this one, 3 times as fast. So I'm probably going to get 6 answers from here. So the normal answers for the cosine being 1/2 would be pi over 3 and 5 pi over 3. But I'm going to take this one and add 2 pi again. I'm going to take this one and add 2 pi and so on. So then I divide everything by 3 and then I get these solutions down here. This one, what you have to do is use your imagination and fit them into the formulas. Which formulas might you ask? Well, it looks like the first ones are the sum angle formulas that you're going to be using. You might have to use the double angle or maybe the half angle if I give that to you, but it looks like the sum angle formulas you need. So if I rewrite 19 pi over 12, I want to put it into factors that I know. Usually if I'm divided by 6 or I'm divided by 4, I'm okay. But out of 12, well, this is 22 twelfths minus 3/4 would give you 19 over 12. And so that would be one that I use. There's probably other ones that you could use that are angle measurements that we know and love. So this one, 11 pi over 6, we know. Pi over 4, we know. So now I can rewrite this as sine of 11 pi over 6 minus pi over 4. So we go back to our formula for the sine, and we say the sine, cosine of the respective angles. Then with the plus or minus, this is minus, so this is minus with the sine. And then sine of pi over 4 and cosine 11 pi over 6. So if I find those values, then I multiply them out. Now some people have trouble with this, but when you multiply fractions, you multiply across the top, you multiply across the bottom. So on the bottom I'm going to get 4, and on the top square root of 2. This one over here I'm going to get square root of 2 times square root of 3, which is square root of 6, all over 4. Since both of these are all over 4, I can write them as one fraction. Some people have trouble with these fractions. See, make sure you understand this. Okay, then this one turns over degrees. We haven't done that much. Excuse me, but you can do tangent 75, 45, and 30 work out for us. And so we plug these things in just the same. Now with this one, when you plug these in, you get compound fractions. So you have 1 over square root of 3 and 1 over square root of 3 with these. When that happens, you got to clear the fractions. So I can multiply this by square root of 3 and this by square root of 3. When you do that, you got to distribute. So if I take the square root of 3 and multiply by the 1, I get square root of 3. If I multiply the square root of 3 times this, the square root of 3's cancel, and I'm left with a 1. Similarly, same thing on the bottom. Now, some places they say don't leave the radical in the denominator. I don't care, but if you wanted to get rid of it, you'd multiply by what we call the conjugate. So the conjugate from the bottom of square root of 3 minus 1 is square root of 3 plus 1. So I multiply top and bottom by that, so that's just like multiplying by 1. And then if I expand this out, I get these. I'm okay with leaving it right there. All right, then this one, when you see pi over 8, what happens with the pi over 8, we don't know pi over 8, but we do know pi over 4, which is half as much as pi over 8. And so I can rewrite this as, I think I said that wrong, but if I rewrite this as pi over 4, all divided by 2, that's equivalent to pi over 8. And so this becomes my u in my other formula. So if I take this here, this is my u for the tangent. Let me look at that again. So I'm not using the double angle formula, I'm using the half angle formula. So here it is. So u right here would be the pi over 4. So wherever I see u over here, I'm going to plug in pi over 4. And then I'm just going to use 1 minus cosine all over the sine. So I have now u is equal to pi over 4. So I plug in 1 minus cosine of pi over 4. Looks like I did that one wrong. So I need this one to be the sine on the bottom here, so that this would have to be sine of pi over 4. So I have to change that. And so I get 1 minus square root of 2 over 2 all over square root of 2 over 2. Now if I want to clear the fractions on this, what I have to do is multiply top and bottom by 2. So I'm going to multiply this by 2 and this by 2. When I do that, I get 2 minus square root of 2 all over square root of 2. Now you might not like that too as well because we have the square root on the bottom. So if you want to multiply both in top and bottom by the square root of 2, you can do that. And you get 2 square root of 2 minus 2 all over 2. And I think the 2's cancel there as well. A lot of canceling out there, and so I get square root of 2 minus 1 is the end of it. Square root of 2 minus 1. If we check on our calculator, tangent pi over 8, look at what it gave us though. It gave us the square root of 8. Well, what's the square root of 8? Well, that's 2 square root of 2. So if I simplify this, then I end up with square root of 2 minus 1. And that's just the same exact thing that I did on the other. Now for these type problems, these are fun. Okay, so you got a lot going on here. Find the exact trig values given this information. Both are in quadrant 4, so that means that the cosine's positive and the sine is negative for both of the angle measurements. So if I give you the sine is equal to negative 4/5, the cosine's got to be 3/5. You can build your little triangle and figure that one out, but it comes from a 3, 4, 5 triangle. This one, however, 5 over 8. That one's a little bit trickier. So you can build your triangle with this information. Cosine is adjacent. So if I call this theta, it's adjacent over hypotenuse. So what's the length of this side? Well, it's going to be 64 minus 25, which I believe is 39. Take the square root. Don't forget to take the square root. And so that would be the other side. So when I'm looking at the sine, it's going to be opposite over hypotenuse. I apply the negative because they tell me I'm in quadrant 4. So pay attention to that. Then you can figure out the tangent from both of those numbers as well. Now if they ask me to find the cosine of u minus v, write out the formula. So cosine with the negative means that I go cosine, cosine, positive, sine, sine. Now some people were messing this up because they were writing cosine of 3/5. No, 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 no. The cosine of u is 3/5, so you just replace that out. Cosine of v is 5/8, so you just replace that out. And those are the values that I have from over here. And then the sine, I get both of those values. And so I get 15 plus 4 square root of 39 over 40. For the sine of 2u's, I use the identity. I take the 2 sine of u and I replace it with the negative 4/5. Similarly, the cosine. Multiply across the tops, multiply across the bottom, see if anything cancel, and I get that there. Tangent one, it's pretty much the same thing. You use the tangent values. When I originally did this, I messed up. I didn't put in the negative. Yes, the tangent's negative in the 4th quadrant, so I have a plus there, and so this would be a negative, which overall makes a positive. And similarly for the sine of u plus v. Hopefully you can sort those out. Verifying the identities with these. Some things to look for. Try the hardest side first. This one you just had to simplify, so it's cosine squared plus sine squared all over cosine. You had to get a common denominator, and then the numerator is 1, so you get that. This one, factor out the sine squared and the cosine. Look to see what's in common, factor it out, and you're left with 1 minus sine squared, and that should get you home. This one, try to use the sum angle formula. Sine cosine minus sine cosine. When you do that, you evaluate the cosine of 3 pi over 2. Leave the sine of x alone. Evaluate the sine of 3 pi over 2. And then you can plug that in and evaluate and figure out what that turns out to be. This one, sine of x plus y, ooh, that looks like, add them up, split it up. And then you can do the rabbit method to split this up, and it should work out. I know I'm going through these quickly, but you can also ask me in class. This one, cosine of 2u. I want to show that it's this. If you notice, these don't have the 2u. So I need some way to translate them over. Well, I do know the formula for the cosine of 2u, and I do know a formula for the sine of 2u. Sine of 2u, straightforward. The cosine, I don't know which one to pick, so I'm just going to use this one straight away. And if I look at this, I can do the rabbit method with this one as well. So I put cosine squared all over this, and notice that one of the cosines cancel. So I get cosine over sine all over 2. Similarly, I'm going to put the sine squared over this, and I'm going to get this here. This is just the cotangent, this is just the tangent, and both of them are over 2, so I'm done there. Sine of 3 theta. Okay, now this is where people get confused. I'm doing identities, so I need maybe to use the double angle formula to sort this out. When I'm solving, usually I like the sine of 3 theta because that just tells me I'm going 3 times as fast. But under this situation, I might need to use the double angle formula, the sum angle formula, and take 2 theta and 1 theta and put them together. So the sine of 2 theta I put here, and then the cosine of theta I put here. So this is just the sum angle formula again. And then I'd have the sine and cosine of the other respective angles out of that. Then I take this one and I change that over to another 2 sine cosine, but I already had a cosine, so that makes it squared. And then this one I change over to the cosine double angle formula too. And then that should simplify out. Ask each other if you have problems with it. I can't say every step of the way, but we'll try. Okay, prove the following. If I ask you to prove this type of theorem, then I want you to write it out. Sine of u plus u. And then this should be straightforward as long as you know the sum angle formula. Tangent u over 2. Well, I would maybe give you these formulas. They're down here. So you can just write both of those. And then once you have the half angle formula, then you can put that together, and then you have to rationalize the denominator. And once you do that, you get this right here. What is this? Well, that is the sine squared. Now, the only problem with this is that I probably want to put absolute value there, but we're not going to pay attention to that too much. All right. Now, for these, if I give you if I tell you I want a problem with the arcsine in it, what happens is that this is overall an angle measurement. It wants to know the angle measurement where the sine is -1/2. Well, what angle measurement gives me that? Well, there's infinitely many. But we want this to be a function, so whenever you see the arcsine, they're only asking for one value. If I had the sine of theta is equal to -1/2, well, then I probably want multiple values. But with this arcsine, I just want one value. So the arcsine would be -1/2 right here and right here. Well, for the inverse sine, which is the same thing as the arcsine, we're just looking at quadrant 1 and quadrant 2 because I only need one answer. And it's going to be from -pi/2 to pi/2. So I want this down angle right there, which would be -pi/6. Is that between -pi/2 and pi/2? Yep. And for the cosine, remember, should I say the arc cosine of x, it's always going to come out of quadrant 1 or quadrant 2. Arc secant is going to go the same way. And then if we have the, this would be the arc cosecant would be in 1 and 4. What did I say down here? 1 and 4. And then the arc tangent would be also in these two. Okay? So if I look at this, now if the sine is on the outside, this is no problem. If you see the regular trig function outside, this is to build a triangle. This is build the triangle method. So if I do that, I use the insider information, the 3 and the 4, and find the missing side. Oh, is it 5? No. 16 minus 9 is 7. So when I read the sine off of here, that would be opposite over hypotenuse, which would be the square root of 7 over 4. Now, some people would like to write sine is equal to that. Well, just say this whole thing is equal to square root of 7 over 4. That's it. Okay, now this one has the arc cosine on the outside. When we do this, we have to pay attention to the domain issues, or I'm sorry, the range issues, and that's what we're dealing with here. So 7 pi over 2. Where is 7 pi over 2? So if I go here, 1 pi over 2, 2 pi over 2, 3 pi, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2 is down here. So that would give me a cosine value of 0. Well, I don't want 7 pi over 2. This one tells me that I need it between 0 and pi. So the other place between 0 and pi where the cosine is going to be 0 is at pi over 2. So this is an angle measurement where the cosine value gives you this value right here, which is 0, and that turns out to be at pi over 2. Don't just cancel those off because it's not spitting it out in the range that we want. Okay, this has the sign on the outside, so this is a build a triangle thing. Tangent, so it's going to be opposite over adjacent. So this is going to be square root of 16 plus x squared. Read off the sign, which is opposite over hypotenuse, and that's what we get there. And then simplify this. Okay, this has the trig function outside, so this means draw the triangle. And so when I build this arc sine of 4x, that means that this is 4x and this is a 1. Opposite over hypotenuse. Secant is going to deal with the adjacent, so it's going to be 1 minus 16x squared. Yeah, you square the 4 and the x. And so when I do this, the secant is the, well, cosine is adjacent over hypotenuse, so it's going to be hypotenuse over that, so it's going to be 1 over 1 minus 16x squared. Okay? You could rationalize that, but I'm okay with this. All right, that runs you through the review. I hope this is okay and you found the pieces that you needed to find. And also you can ask questions in class and we can take care of you in class as well. Have a great time studying for this and trying to sort all this out. If you had trouble with some of these, go back to the problems in the book and see if you can find some that will help you practice it some more. Have a great evening, day, wherever you're at. Thanks. Bye.